Okay, so in this one we're told that it's a circle in the first quadrant and that both the axes are tangents, and also we have a tangent line of 3x minus 4y plus 6 equal to 0. Okay, so I'm going to work with the equation of the circle of x minus h to be squared plus y minus k to be squared equal to r squared. Now it'll work just as well with x squared plus y squared plus 2gx plus 2fy plus c equal to 0. We just need to be a little bit more careful if we're using that one, because we have our center of that one to be minus g and minus f, so we kind of need a sign change. So just it can cause maybe a problem when it's not necessary. Okay, so the center of this is hk, and then if I just start drawing in my tangents, okay, or my normal lines to my tangents rather. Now what we will see then is the center is hk of the general equation, but for this particular example, okay, this here, the length of this line here is h, and then because they're both tangents, we know that h is equal to k. Okay, so that means this is also h, and our center, like we had, was hk, well now it's going to be hh, and then the length of our radius is also h, because basically all of these blue lines are radii. Okay, so what can we do then? Well, what we know is the perpendicular distance from this hh out to our tangent line has a length of h. So we're going to set up a perpendicular distance from hh, which is our center, to our line, which is our tangent, 3x minus 4y plus 6 equal to 0. And we know the distance from this is h units. Okay, so setting this up then, so I'll write down my formula first. ax1 plus by1 plus c all over a squared plus b squared is equal to my distance. So in this circumstance then it's 3 times bracket bracket minus 4 times bracket bracket plus 6 all over the square root of 3 squared plus minus 4 squared. Now I always set it up like that first so I don't mix up the a and b on the bottom. And now I'll put in my point, which is hh, and I'll put it equal to my distance, which is also h. Now working this out on top, then I have minus h plus 6. On the bottom I have 3 squared is 9 minus 4 squared is 16. So 16 and 9 is 25. Square root of that is 5. Not forgetting my absolute values equals h. Okay, so then I have that minus h plus 6 is equal to 5h. Okay, so we'll take two cases. Minus h plus 6 could be positive, or minus h plus 6 could be negative. So there's our negative version, or it could be positive. Okay, so what do I have here then? Well, this will give me 4h is equal to minus 6, which will give me h equal to minus 3 over 2. And that's not possible, because that will give me a h in the wrong quadrant. Okay, because h is in the first quadrant, so it's positive. Okay, so working with this one then, I'll get minus 6h is equal to minus 6, so h is equal to 1. Okay, now what do we know about k then? Well, we said at the very start, because the x and y axes are tangents, h is equal to k, which is also equal to the length of the tangent, the radius, which means they're all equal to 1. So using my general equation of a circle then, or my equation of a circle in this format, it's not really called the general equation 1. Filling in those, I get x minus 1 squared plus y minus 1 squared equal to 1.